Okay, I think we've got this all set up and ready to go. We're not going to waste any time with hardware edits and things like that. I'm going to also use my phone camera to capture the multimeter view and the unit view just so we can see the setup. But that's in the other room, so it might be a little bit noisy. Hopefully not too bad. Yeah. Additionally, I'm going to come over here. I want to verify that, yes, Helix, grounded Helix is scaled to 20 milliamps. I've reset the calibration for this guy. Additionally, we're going to be calibrating bias voltage, which is set to -1 and 0. Based on some math internal to the unit, the gain has to be negative. And pulse top is 1 and 0. So we have verified that the three calibration factors that we're setting today are correct. Let's start with bias and pulse top. Those are going to be fairly straightforward, and in fact, I did verify yesterday that they can all be done from right here in the calibration window. There is no specific turn-on sequence using our standard set of buttons. I mean, we could, but it's a little bit safer, a little bit more straightforward. So first thing we're going to do is we're going to go over to the unit and we're going to set up our voltage measurement on the multimeter, and we're also going to ground the cathode. The reason we ground the cathode is, one, for safety, and two, it also stabilizes the measurements of the bias and pulse top voltages so that there's not a lot of drift and we can calculate our gain and offset accordingly. So I'll be right back. Emergency off switch. And on this breakout box I have cathode right there and I have ground right there. Now cathode is grounded. Re-enable, and I'm going to start it back up from the office. So what I did was I set -100 volts into the bias, and we are going to adjust offset. Let's go 1 and 0. And we're going to adjust offset until this reading matches the meter. So let's turn on the grid. We see 100.843-ish. Let's see what the DMM says. 95.17. So now let's adjust this offset until our reading reads 95.17. Five. 5.1567. And something close. It's going to have some jitter. It's super annoying. And we're going to call that good. Now let's bump this up to 1500. The customer can pick their target value, of course, whatever they want to run the bias at. And this would be an ideal calibration point for them. So I see 1485. Let's go see what the DMM says. 1419.0. Got 1419.0. $14.19.0. So that's definitely too far. We're just going to adjust gain until we read 1419.0. Like so. Let's take this back down, and we're going to do successive approximation of about 3 iterations in order to get our 14. Did I say 1419 and 95? Let's go see what that meter says.
Still at 95.17, so the DAC has not caused any drift in the set point. 95.17.
95.17, we have 1419.0. So we're going to readjust to read 95.17. Like so. 1.206. Okay. Let's take this back to 1500.
Double check that this is still at 1419.0. It's 1419.3. Let's recalibrate gain to that. 1419.3.
So 1419.3 using our gain. There's 0.3. 1419.3. Let's also drop back down to 100. This will be the last time. I usually can get it pretty close within 3 iterations.
It's still at 95.17.
So at 95.17, I'd say we're close there. And one more time at 1500.
And we are solid at 1419.3.
So one more adjustment to 1419.3 using gain. Like so. And let's drop back down to 100 once. 95.15 versus 95.17. I'm happy with that. So we're going to store. Essentially what we're doing, especially for the bias, is we're assuming that we cannot reach 0. We cannot turn off and ground the grid and take an offset. So we have to do this with both points powered up. And at a low end, the lowest end we can get, we're going to say 100 volts negative. We're going to adjust offset, and 1500 volts negative will be our gain adjustment. All right, let's move on to pulse top. A lot of people like running the pulse top positive. But this would depend on, of course, their own set of parameters. The lowest we can run the pulse top is at 0. It actually can reach 0, but it is difficult to adjust. So what I would recommend doing is run it at a relatively low positive voltage if they want to run it consistently positive. And let's check what that DMM reads right now. So we should see positive 50 volts on the DMM.
For whatever reason, we're still seeing minus 100. So I'm going to go check my connections and all of my settings and make sure of this. Be right back. Alright, so it took a couple iterations, but I finally got it to output on the pulse top supply at 100% duty. And you can see I have about 45 volts, which is what we read on the GUI. 44.79.
I'm going to write down 44.79. And I'm going to adjust offset until we read that, which we are reading exactly 45.0. So we need to bring offset up 44.79. Approximately there. 44.787. Now let's boost pulse top voltage to 350. Its maximum is 400. So we'll take it to somewhere close but not quite. And this could be set by the customer to their own ideal value. I see 339.4. Let's see what the DMM says.
338.3.
So 338.3 is our high end. Let's adjust gain so that we see that in the GUI. There's 6, 8, 4, and drop it a couple counts on the next digit over until we get 338.3, like so. Now, let's drop it back to 50 and check that number again. 44.79 was our previous. Let's see how much it's drifted.
And we have at 44.6. 44.6.
44.6. Let's adjust offset. It's actually really close already. We're going to leave it there. And then bump this to 350 again. Check the drift on the meter.
338.2.
At the high end, we adjust gain to make 338.2. 0. Like so. Let's go one more iteration just to be consistent. 3 iterations of successive approximations. So at 50,
44.6.
and that's exactly what we see is 44.6. I'm going to say this is good. So we're going to hit store calibration table in Flash and call it good. Now we can turn off our grid. Clear false. And head over to Helix current. Now let's go set up for Helix current measurement.
So here what we've got, we're going to disable our burn-in unit. We're going to take out our measurements. And we're going to take our 1.4 mega ohm load, and we're going to set up a meter on this guy. So we're going to leave ourselves a little space, just because this lug is going to be running from cathode, and this is going to be running from ground. Let's grab our handheld multimeter. And we're going to wire this, the multimeter, to the ground lug of our breakout box. This is earth ground chassis, okay? And the other side of the multimeter, we're going to wire to the bottom of our load. Now they can pick out the load that they need to run the current, or run the current that they want. The Helix will run up to 20 milliamps. So if they need something higher, they'll need to create a lower value load. This one I think runs at around 8 milliamps or so maximum. Let's also wire up our cathode to the top of the load. And we're going to run this cathode at around 12,000 volts. So this will be running at 12,000. This will be at 0 across a 1.4 meg. We can do the math. But I don't want to because I'm terrible at head math. So let's turn this guy on. We see 0 milliamps right now with it off. First step, we're going to actually calibrate offset like we do all the other currents. First off, let's remove measurement devices from ground. All measurement devices. We can leave the ground wire to the wall in place, but the Ross divider wire, let's get that out of there. Any sort of ground current will count toward this measurement. So let's also remove these jumpers from the breakout box. This should be irrelevant. These are grounded internally. This is for 2-wire Helix measurement. This unit and this procedure does not apply to 2-wire at this moment. So let's head back to the GUI and adjust offset to make sure Helix current is at 0.000.
All right, currently we see about 700 nanoamps, and we can adjust that out. Add a couple, like one more 0. And we can get that fairly close to 0. It's to where it's bouncing between negative point whatever to positive point whatever. All right, let's reconnect that load and get it up.
Okay, so top side to cathode, bottom side to ground. We're now going to re-enable the supply. It can now be turned on, can be hot. This is dangerous. We're still at 0 milliamps here.
Let's disable faults and turn it on. We're starting at 1500 volts cathode. This is the lowest the cathode can run. Bypass heater timer, turn on high voltage. Still no current, and close the cathode switch. Now we see about 1 milliamp, 1.09 on the cathode, 1.05 on the Helix. This is uncalibrated. Now what we can start to do, I've got a set of recipes here that will slowly step up this voltage. We also want to take our Helix current limit, trip level, up to maximum. Let's also double check. We need to make sure that our maximum is also at 20 milliamps, same as our scale. We're going to take this up to 20. Recipes always overwrite that, so I'm just going to manually type in 20 after I load the recipe. I double click voltage range 2. This sets it to 3000, and I activate. I can now see 2.1 milliamps. Let's go the next range up. Restore, type in 20, and activate. And I now have 6000 volts, which is double 4 milliamps. And our last one is at 12,000 volts. I set 20 milliamp current limit and activate. And now I have 8.401 milliamps. and 8.658 milliamps on the cathode. Let's also set this to 100, just for the sake of consistency, so that we see on our sample and hold current, the cathode is equal to the average current. So let's head over there and see what the meter says.
And we had 8.65, and we see 8.65 milliamps on the cathode, which is exactly correct. As you recall, cathode already reads 8.65 in the GUI, which means it is calibrated.
So we've verified that cathode is calibrated. Let's simply take the gain of Helix current and match up the reading with cathode current. .660. Enter. And we're calibrated. Let's also test our trip level by setting 9 and 1 volt at a time. We're going to nudge cathode up. We can slowly see Helix current increasing. Let's go 10 volts at a time. And we tripped somewhere below 9 milliamps. So the analog trip circuitry is not calibratable, but it is lower than what our calibrated reading reads, which is safe. We can also double check this. If we set 2, we should see 2 milliamps when we boot up at 4 milliamp trip current. So we restart it, TWT, immediate Helix fault. There's some noise on the Helix when you initially start it up, so it's good to get that out of the way, at least on this setup, especially with this resistive load. So we're going to run it up to 2 milliamps. We're going to set 3 milliamps trip, and we're going to take it 10 volts at a time up. And just keep going. 5, and at 2.26 we tripped with a trip level of 3, which I consider adequate. So we've tested the trip functionality of the Helix at multiple trip points. We can now assume that this is calibrated. We care more that this reading is accurate to the meter, as long as the actual current at which it trips does not exceed 3 milliamps or 4 milliamps or whatever the set point is that we've set. And that's how to calibrate Helix. So we'll just hit this store calibration table in Flash, and we're done.